Right, we'll continue on with our question ones, and this one looking at an oxidation reduction titration, and we're going to determine the percentage of hypochlorite in bleach. So many bleaches contain hypochlorite in the form of sodium hypochlorite or calcium hypochlorite. Generally that hypochlorite ion you might see written as OCl minus or ClO minus. So the compounds which that might be bonded to might be NaClO, NaOCl, whatever, or CaClO2 calcium hypochlorite, something like that. So we want to see what percentage of this hypochlorite ion is present in bleach. So if you look inside of your bleach bottle, you'll see 5% sodium hypochlorite, nearly like your vinegar experiment. So there's a lot going on in this because neither are primary standards. So there's generally two equations. You might see it given in the question that they assign, but don't be put off, we'll not use the ratio here. But in your conical flask, you'll make up your iodine solution. Now in order to make up that iodine solution, you have your bleach, which might be written as NaClO. There's your hypochlorite ion, your diluted bleach. Again, you need a diluted amount, otherwise an excessive amount of reagents would be required. You have excess potassium iodide, excess Ka, and you'll need excess sulfuric acid. And when we mix them three reactants or them three reagents in the conical flask, we produce an iodine solution, A2. Now a lot of the time they ask you why do you need an excess amount of Ka? It keeps the iodine in solution and ensures all the bleach reacts. So what it means by keeps the iodine in solution, what you actually form is triiodide ions. So there's my iodine. Iodine I2 shares electrons equally if you're looking at electronegativity difference between them. And the intermolecular forces there are van der Waals forces. So it's a non-polar substance. So if it's a non-polar substance, it's insoluble in water. So excess Ka, so there's plenty of that. And what you form is triiodide ions, I3 minus triiodide. Since it's got a charge, since it's a polar, it's going to be soluble in water. So that's what it means. Keeps iodine in solution. You don't form two layers, one solution in water. And when you produce iodine, even if you think from your junior cert or if you're a fireman, you spray iodine on a lamb's navel, it's a red-brown colour. So at the start, you have a red-brown colour of iodine solution in the conical flask. So once you've got this iodine solution, you go up here and you're going to titrate it against sodium thiosulfate. Now sodium thiosulfate is in your burette, your iodine, or your I2 is down here. So your sodium thiosulfate is in your burette, your iodine is down in the conical flask. And remember that we lovely questions. How do you prepare your burette? Rinse with the ionized water, then the solution is contained, to coat the sides, sure the portion that below the tap is filled, etc, etc. What was I saying? Oh yeah, so you've got a red-brown colour down here in the conical flask. You add in your sodium thiosulfate until it goes a pale straw yellow. Now it's very hard to see the difference in a pale straw yellow and a colourless. So when it's pale straw yellow, there's still a small amount of iodine in it. So to test for iodine, use starch indicator, or you might have learned from junior cert. In your food test, to test for starch, use iodine. And iodine and starch goes what colour? It goes blue-black. And when it goes blue-black, there's only a small amount of iodine left, so you'll not need so much more sodium thiosulfate in it. So you add in a few wee drops and it should go colourless. So like if that comes up, generally nice marks, red-brown, go pale straw yellow, you add in your starch indicator and then it goes colourless. And like your vinegar, this is the reason I did it. Like your vinegar, there's a dilution factor on it. So this is what we've done with 6th years, haven't looked at it in 5th years. We'll be looking at it till next year. So I'm going to do the 2011 Leaving Cert question been a while since it's been up. Again, it hasn't been first principles. There was a question in 2015. I was looking at iodine, sodium thiosulfate. So they break up this into two. Realistically, they're both the same. So the bleach, I'd be backing like a washing crystals or a vinegar, and I might do my iron tablets as well. So that's generally 4 of them, 6, 7 experiments, and you've done the water. So again, I'll not really read through the questions. It's the 2011 one, got a wee link below as well. So we'll just work through it. The first thing here, once we have all the information, this was provided in the question, I just didn't pick this out or make this up. Once we have all this information, the volume and the molarity of our sodium thiosulfate, I see the big M, I can work with that. So what does that allow us to work with? The number of moles of sodium thiosulfate. So 0.1 M, straight away that means 0.1 moles per litre. And remember, 1 litre is equal to 1,000 centimetre cubed. Now how do we say this in maths? Remember, that thing just means in, 0.1 moles in a litre. We simply put it over. So 0.1 and 1,000. Now how much did we have? 16.1. You fire that in your calculator and we'll get 0.00161.1 over 1,000. Multiply that by 16.1. 0.00161 moles per 16.1 centimetre cubed sodium thiosulfate. And remember, that might be given in scientific notation as 1.61 by 10 to the minus 3. Perfect. Next thing they'll ask you is for the number of moles of iodine. And like we always do in our stoichiometry, the ratio of iodine, or triiodide ions, to thiosulfate is 1:2. Therefore, to work out, we've got that there's 0.00161 moles of this. To work out the number of moles of iodine, simply divide it by 2. So the number of moles of iodine is 0.00161 divided by 2. So just never delete that number from your calculator. 0.000805 moles per how much? 25 centimetre cubed. And that bit's crucial, of I2. Then more likely they'll ask you for the concentration or the molarity of I2. Now the molarity means it's the big M, the number of moles in a litre. We've got the number of moles in 25. How do we say that? In, we put it over 0.000805 in 25, and then bring it up to a litre, times or by 1,000. So answer over 25. If you're good at the maths, you could just say multiply by 40, and you get 0.0322 and a big M of I2. Then they'll ask you, because that's technically not the bleach. The bleach, remember we said, was this NaClO. If you're working back, so we've got, this is the number of moles in a litre of iodine here. Still in a 1-to-1 ratio, it's the number of moles of iodine here. And that's in a 1-to-1 ratio with your bleach. So we've got that many moles of sodium hypochlorite as well. So we've got that many moles of iodine. That means we have that many moles per litre of NaClO. I'm just looking at the 2011 question on E part 1. Calculate the concentration of NaClO in moles per litre in the diluted bleach. And that is of the diluted bleach. So that means there must be a dilution factor in here somewhere. In the question, I have it written down over here. It's 25 over 500. It's a 1 in 20 dilution, but if you're ever unsure, 25 over 500, 1 in 20. So to work out what the original bleach is, or the undiluted bleach is, we multiply it by the dilution factor. So we times that by 20. Zero 0.644 moles per litre NaClO, and that's of the bungus over now. NaClO, and that is of the original or the undiluted bleach. Now that is the answer to E part 2, if you like. I have them labelled all sorts of ways here because I made up these questions because it wasn't first principles. And then the last thing, what was the concentration in the original bleach in grams per litre? That big M means moles per litre. To go from moles to grams, you multiply by the relative molecular mass. And NaClO, 1 by 23, just using the mass numbers. Chlorine and copper, remember keeping your wee halves. And oxygen. And you add up all those, you get 74.5. So number of moles per litre times that by 74.5, 47.978 grams per litre. And then the last one they ask you is percentage. I'm on F part 2 now. F part 2, they ask you for the percentage weight per volume. Percentage just means out of 100. Weight in this case just means grams per 100 centimeters cubed. Different ways you could do that. Some might just simply divide by 10 because you've got the number of grams in a litre or 1000 centimeters cubed. To bring it back to 100 divided by 10 and you get 4.7978 percent or 4.8% weight per volume. Someone else might say, like we did throughout, that thing means in. So 47.978 in a litre or 1000 centimeters cubed. To make anything a percent, times that by 100, throw that in your calculator, and you get an answer of 4.7978% weight per volume. Now what I would do is highlight all these answers that they were asked us for. There's F part 2, just so you know what you're looking for when you're going over them. And I would do this in the exam as well, keep the examiner happy, unless you made a hames it. F part 1, original bleach we have up there, and the diluted bleach there. The rest they would ask you for them, you'd imagine, in the first principles.